Hello everyone, welcome back to VMAC1114 College Trigonometry. Now let's go back to the main goal of trigonometry. Our main goal of trigonometry is to calculate the angle and the side of a triangle, right? And so far we already learned some relation that help us to do such thing. We know that in the right triangle, we take sine of one of the angle could be opposite over hypotenuse. So those relation we've been using it just for right triangle only. Then how about if they give you a random arbitrary triangle? How are we going to calculate it? So in this video, I'm going to show you a formula, a relation that help you to calculate the sine and the angle in any triangle, not just the right one. Okay, so in this video we will be talking about section 6.1 section 6.1. okay, we'll be discussing a relation we call that a law of sine. Okay, so let's get started. Section so over here I put section 6.1 law of sine. Okay, law of sine. Okay. So what is law of sine? Well, I just say that the law of sine can be used in any arbitrary triangle. So I'm gonna go ahead and draw a random triangle. Okay. So my triangle is like this. So let me use so just draw a right triangle. Not right triangle. Just arbitrary triangle. I'm sorry. Arbitrary triangle. So I'm going to call this this is angle alpha. Okay. Okay. This is angle beta right here, and this is gamma. So this is side B, and alpha will be opposite side. The alpha will be A, and this is C. Okay, so this is an arbitrary triangle ABC, you can say that. And the law of sine states that if we set up the ratio sine of alpha over A, it will be equal to sine of beta over B, and equal to sine of gamma over C. There you go. So we have a proportion. Okay, proportion amongst three ratio, not just two. And remember that if we have the proportion, in order to solve for the proportion, we're going to use a cross multiply, right? A cross multiply property. Remember back in no, that's pretty long time in intermediate algebra. So this one we're going to use the cross multiply property here. Okay, to solve for the proportion, because this is a proportion. We have three ratio equal to each other. But whether or not, when you solve the any triangle, whether or not we can use this law of sine directly or not depends on the information they give you in the question. So it depends on the number of information they give you in the triangle, so that you should use law of sine right away, or we have to do something else in order to see like how many truly triangle you have to solve. So I'm gonna just go ahead and categorize into two different cases, and in each case it has the different information. And it helps you to determine whether or not you should be able to use the law of sine directly. Okay. So on the first case, case 1, So the triangle I'm trying to show, giving you three information. They give you angle, sine angle, or they give you angle, sine. Okay, angle, sine, angle. It means that they give you the a triangle. Now let me start with the first example here. In the first example, I have again I have a random triangle. Okay, it's not really. Let me erase this. A random triangle, and they give you that angle. So they give you the angle over here. So I'm gonna call the triangle ABC, and they give you the angle over here is 75.8 degrees. So they give you one of the angle, and they give you the sine. It's 10.2 inches, and they give you an angle over here is 45.1 degree. So you see that they give you angle, sine, and the angle, sine, and angle. So the sine must be in between two angles. And the question is, solve this triangle. When you solve triangle, it means that you gotta find the other information, the angle and the length of the other side in that triangle. Okay, so in order to do this, okay, we see that because this is the first case, angle, sine, angle, and angle, sine. This is the case you can use the law of sine directly. But in order to use the law of sine, you must know the angle, at least a few angles, and they already given you. Now we can find the third angle easily. So angle alpha over here would be 180 minus 75.8 plus 45.1, which is give you 59.1 degree. Then we're gonna apply the law of sine. So we're gonna set up sine of alpha will be sine of 59.1 over A. A is the other side, the opposite the angle alpha. So 10.2 sine of 75.8, which is angle beta, over what? Over what we don't know, right? Over AC, equal to sine of gamma, which is sine of 45.1 degree, over AB. So our job is to find AC and AB, and you see this is a proportion. We can use cross multiply. We just go ahead and pick up this part of the portion. So we're gonna pick this one, and we cross multiply. So we're gonna have AC sine 59.1 equal to 10.2 times sine 75.8. And now we can solve for AC. We just go ahead and calculate them out. Calculate this out. You divide both sides by sine 59 over 1. So from here I can get AC is 11.5 inch. Okay, cross multiply. Okay, just calculate this out, divide both sides by this. So I think I'm gonna go ahead and try another step for you. So we're gonna have 10.2 times 75.8, and you divide it by 59.1. Then you got AC is 11.5 inch. Okay, that's the AC. Now you're gonna do the same thing for AB, and you're gonna pick the first ratio and the last ratio. So we're gonna go ahead and solve for AB. So AB sine 59.1 10.2 times sine 45.1 You can pick this one too, but in that case you're gonna pick the information you just calculated, 11.5. Just think about if you screwed up AC, right? It means your AB will be wrong. So you don't want to pick this. I mean, even though you can. So from here, we can get AB will be 10.2 sine 45.1 over sine 59.1, and you got AB will be 8.42 inches. Alright, so we got everything. We got AB, we got AC, we got BC, and 3 angles. So it means this is done. That's a nice problem right here. Okay. Alright. Now the second example, I'm gonna give you so that I'm gonna give you the case where we have angle sine. So second example. Angle sine. Okay. So again, I'm gonna give you a random triangle. Okay, and this is 38 degrees. This is 63. So they give you two angles, right? Angle sine, and one of the side given must be opposite one of the angle. So they give you 12 inches here, and this is alpha. Alright. So in order to solve this one, it's easy. We can go ahead and apply right away. So alpha, we will do the same thing, will be 180 minus 63 plus 38, which is give you 79. And now we can apply the law of sine. So sine of plus 79 over BC equals sine of 63 over 12 equals sine of 38 over AB. And now see that we can use cross multiply over here, right? So sine 63 BC times 12 sine 79. So from here we got BC be 13 inch. Okay. Same thing we can solve for AB. So AB sine 63 equal 12 sine 38. So from here we got AB, which is 8.29. Alright. Okay. So that's the first case. Now the second case is where you cannot implement the law of sine directly. You gotta calculate something before, okay? Before you can implement law of sine. So case 2, when you have a triangle, and the information they give you in the triangle is sine angle. Okay, and the information they give you here, sine angle, one of the angle over here, I mean the angle they give you over here must be opposite one of the side. Shall I put a ring mark? So angle here must be opposite one of the side. Okay, so this is you use this the remark here to determine it is the first case or the second case. Okay. If you see if side angle, then you gotta do one thing. You gotta calculate the h value. Okay, h value. So I'm gonna put this in. Let's see. Let me pick a different color right here. Orange. Okay. So you need to calculate the h value. Okay. And the h value is equal to b sine alpha. B sine alpha. So the alpha here is the angle. The alpha here is the angle given. Okay, this is the angle right here. That is the angle given. So this is alpha here is given. Okay. The b will be adjacent. The b will be the sine adjacent to alpha. Okay, adjacent to alpha, not opposite. Okay, adjacent to alpha. Okay, and then after determine what alpha and the b value is, then you need to determine the alpha is the acute angle or obtuse angle. If alpha is acute angle, then there are 4 different cases. The first case is the value of a is between 0 and h. So after you calculate the h, okay. The second case is when a is equal to h. The third case is h is less than a and less than b. Okay. Okay. A is the angle opposite. A is the side opposite alpha. So just mark over here. So a is the side opposite angle alpha. And the last case is a is greater than b. Now in the first case, if you have something like this, it means that we don't have triangle. 0 triangle. There's no triangle for you to solve. That's what it means. If a equal h, then we have 1 triangle for you to solve. This is, you have 2 triangle for you to solve. 2, okay? And this is only 1 triangle for you to solve. Okay? So that is when alpha is acute. And if alpha is obtuse, we have only 2 different cases. The first case again, a less than a between 0 and b. In this case we have 0 triangle. So the second case is a greater than b. Then we have 1 triangle. Okay. Now I'm going to give you, so this information is very important, okay? So you must know this. You must know this. So if you see something on the test, then of course you must know the rule right here. So I'm going to box them. Okay, I'm going to box them. Okay, box them. Okay.
Let it go.
Alright. Now I'm going to give you the first example. So in this example, I have a triangle. Okay. And I call it ABC. And I give you an angle, which is angle alpha right here, 34 degree. And adjacent one, this is the B1, the adjacent one, which is 2.3. I mean, on the test, on the assignment, I'm not gonna put this is a B1, you know, but this the adjacent one is the adjacent one must be given. Okay, the adjacent one to the angle must be given. And 1.2 here must be the A because it's opposite A. Okay, and we want to solve this. Okay, so this will be in case 2 because it's sine, angle, sine, angle, sine, angle. So we need to calculate. We need to calculate the H value. Okay, and so we need to calculate H value, which is B sine alpha. So B over here will be what? B will be 2.3 sine of 34 degree. You calculate this out, which is give you 1.286. So the H value over here is greater than A, right? Because A is 1.2. A is 1, so this is greater than A, 1.2, right? And greater than 0. A is greater than 0, right? So it looks like it's in the first case, when A alpha is acute, 34 degrees is acute right here, alpha 34. So this is a 0 triangle. It means that we don't have any triangle to solve. No triangle to solve. Okay. Maybe we can jump into the conclusion like that, but I mean, some of you kind of, okay, why don't we just go ahead and apply the law of sine over here? I mean, it looks like it's feasible, right? But why you jump into conclusion there's no triangle? Now let's use the law of sine to show that we don't have any triangle in this case for you to solve. Now, if we go ahead and apply the law of sine, right? So we're gonna apply the sine of beta over 2.3, right? Equals sine of 34 degree over 1.2, and we do cross multiply. So you will see that a sine of beta will be 2.3 times sine of 34 over 1.2. When you calculate this out, which is give you 1.0718, this is greater than 1. Remember the range of the sine, between negative and 1 only. We don't have the range of the sine is greater than 1. So the range of the sine is greater. How come we can find the B, right? How come we can find the beta angle? There's no way we can find the beta angle. So that's why you see that we don't have the triangle to solve. So this doesn't make sense. This is outside the range. Okay, outside the range. So we cannot solve it, the angle. Okay. All right. So you see right away that we don't have to do this step. We just need to calculate the H value, and we know that there's no chance for you to solve. Okay. Now on the second example, the second example, I have a triangle like this. Okay, a random triangle. So do not draw the isosceles or just or equilateral triangle. Just draw a random one. Okay, a regular one, a scaling triangle. Okay, so this is 47 degree. This is 3.5 again. 3.7. B, C, and A. And I want to solve this triangle. So we know that A will be 3.7. Okay, B is 3.5, and so you see over here is A greater than B, right? A greater than B. So if A is greater than B, you look at the rule. If A is greater than B, and alpha over here is 47, so it's a Q, so A greater than B, so we have only one triangle. So from here, we know we have only one triangle to solve. And we have one triangle to solve. It could be very easy. Just go ahead and use the law of sine. So we can have sine of 47 over 3.7. Sine of beta over 3.5. Okay. And from here we can calculate the sine of beta, right? So we're gonna have 3.7 sine beta equal 3.5 sine 47, and from here we solve for beta. Will be 3.5 sine 47 over 3.7, and calculate this out, and we take the inverse, so beta will be inverse sine of 3.5 sine 47 degree over 3.7. Alright, and if I don't have any mistake, the angle beta over here will be 43.7 degree. So if you have beta, you can, of course you can find gamma. Okay. Then we also can find AB, so sine of gamma over AB. Okay, so we need to find gamma first. So gamma will be 180 minus 47 plus 43.7. Okay, so this is gamma. So after you calculate gamma, you can find AB. Plug over here. So AB cross multiply sine beta will be sine gamma times 3.5. So from here we can find AB will be 3.5 sine gamma over sine beta. Sine beta is whatever it is here, will be sine of 43.7. And here you go, and you're done. Okay, so go ahead and calculate this question mark right over here. Now, in the third example, okay, in the third example, this is the example when you see the special things happening. So I have triangle. Again, I have a triangle like this. I have so what we'll be doing, we've been doing side angle. Okay, we're doing side angle. Side angle. So okay, so I have a triangle like this. So this is the information they give.
Tối mà. Sáng không à?
Okay, and they give you the angle. Okay, and it's just a 26. I don't know. This is angle alpha or beta. It doesn't matter. Like this is it's just in it. It's 26. So side angle. One of the side, right? Let's go back to the rule. Okay, the side, one of the side must be opposite the angle given, and one of the side will be adjacent to the angle given. So they give you this one is 11, and this one they give you 18. Okay, and again I just named this as angle alpha, so this could be A. Okay. Okay, let's name this as angle beta. Okay, and this is gamma. It's gamma. Just name it. Okay. Okay. Now I'm gonna use Because we know this is the second case, so we gotta calculate the h value. So the h value will be b in this case, b sine alpha. B in this case will be the adjacent one, so b over here be 18 sine of 26, and you calculate this give you 7.89, and 7.89 is, you see that will be less than a. Alright, so 7.1, so h value will be less than a, and let's say it with less than b or not. A is this, b is this, so 7.89 is less than 11, less than b 18. So here we can conclude that we have two triangles to solve. Okay, alright, two triangles to go. And the first triangle is you do as usual. First triangle you do as usual. You just go ahead and calculate the law of sine. So we're gonna have sine 26 over 11, sine beta over 18, and sine gamma over c. This is c. Okay. So from here we can calculate sine beta. So 11 sine beta cross multiply 18 sine 26. So sine beta will be 18 sine 26 degree over 11. So from here we take inverse. So beta will be inverse of that. 18 sine 26 degree over 11, which is give you 46 degree. Alright, 46 degree. And so if beta is 46, then we can calculate gamma, right? So gamma will be 180 minus 46 plus 26, right? 46 plus 26, which is give you what? Go ahead and put into calculator. 46 plus 26 minus 180. So gamma will be 108. Okay, that's gamma. So if you know gamma, we can calculate the c, right? So c in this case, c sine 46 equal to 18 sine gamma 108. Alright, from this proportion cross multiply. So here we can get c will be 18 sine 108 over sine 46. Alright, put into calculator. 18 sine 108 degree. Okay. Alright, divide by sine 46. Which is give you 23.79. Okay, about 24. Alright, 24. There's no unit. So, but that is just the first triangle. Because we have two triangles, so we gotta solve the second one. But where could be the second triangle though? Well, we need to solve the second, but where is that? The second triangle will be hidden inside the triangle given, right? So where is that? I'm gonna show you. It'll be here, right over here. First of all, go ahead and take the opposite side of the angle given and draw the isosceles. Okay, draw isosceles. Isosceles. Draw isosceles. So this will equal to that. Okay, draw isosceles. So if you draw isosceles, so this angle right here, okay, this angle right here, which is also angle beta, right? This is also angle beta. This is also angle beta. Okay, because isosceles, this is the base angle the same. And beta we already know this. So the angle right over here, you know what? I think I'm gonna go ahead and this part right here. So okay, and the angle right over here, right here. Okay, we can calculate it. Okay, I'm gonna call this angle right here is angle beta prime. Okay, beta prime. So I can calculate the angle beta prime. So the second triangle is this one right here. This one right here, the pink one right here. This is the second triangle right over here. See that? Right there. So I'm going to show the pink triangle. Okay, so we can find beta prime easily, right? We can find beta prime. Beta prime, I'm going to use this color also. Beta prime will be 180, right? Minus, because it's a flat one, minus beta, so it will be 180 minus 46, which is 134 degree. That's beta prime. Now we can find the angle right over here also. I'm gonna call angle over here is angle right here, the green one right here. I'm gonna call this angle right here is angle gamma prime. So gamma prime will be 180 minus 26, right? Plus 134. You calculate this, which is give you 20 degree. Alright, so we got all the side. Okay, we got all the angle. Now we can go ahead and do using the law of sine. So I'm going to use the law of sine. Okay, so let's put the law of sine in. So we're gonna have what? We're gonna have sine. Okay, sine of 26 over what? This is isosceles, so over 11 equals sine beta prime 134 over 18 equals sine gamma prime, which is 20 over this one. I'm gonna call this one is the C prime. Okay, from here to here. C prime. Okay, from there to there. So this is over C prime. Alright. So from here you see you can calculate the C prime easily, right? So the C prime is C prime times sine 134, 18 sine 20. Then C prime will be 18 sine 20 over sine 134. Okay. Then from here we can get C prime will be what? Put it into calculator. This will give you about 8.582. There you go. So that's your C prime. So we got everything, right? We got C prime. We got A prime. Right. The A prime is here. So A prime is here. And B prime is the same. So A prime is 11. A prime is 11. Okay, and B prime is 18. Alright, so everything's done. Okay. Good. So if you have two triangles, this is how you get the second one. You draw the isosceles. Okay, draw the isosceles. I'm gonna put a mark again. I'm gonna put a mark over here. Draw isosceles. Okay, draw isosceles. Right. So the second triangle is this one. Alright. Alright, so that's going to be the video for Law of Sine. And next will be do Law of Cosine. Let's see how we're going to implement Law of Cosine. It will be easier or harder than Law of Sine. We're going to discuss about that in the next video. Okay, I'll see you next time.